Hello world. In this video, we're going to talk about spectrograms and synthesizing images back into audio and different methods in Facet that allow you to do that sort of stuff. So let's do it. This is an image that I resynthesized into sound in Facet. It comes from this image, which is something I generated in Facet initially. And so here's how you would do that. Once you've got an image, it can be any PNG image, you use this load image method, and then you supply the absolute path of that PNG. So this basically just says like, hey, take this image file and interpret it as if it were a spectral score, where the left to right is movement in time, and the top to bottom is the frequency at each of those points in time. So then you just resynthesize that spectral representation back into audio. That's what this method does. The first argument 1 is the frequency distribution. This is linear when it's 1. 2 is like an exponential distribution. So we can kind of go into that in a second. The second argument is the duration. So this says make a 10-second audio file. So let's run that. We'll save it into this directory here once it's ready. It should look like this image. So I'll just delete that, and then when it's ready, drag it back in. All right, so that's what it sounds like, and you can see if I put my cursor all the way at the end here, it lasts 10 seconds. So we could instead make it last 1 second, delete a 0. Now we've got like a little munchkin over here. And we could change the frequency distribution to be logarithmic. So you can see that's very different looking. Let's make this last 5 seconds, and then this can be a pattern, right? So we could start with 1 and move to 2 over 128 values. Cool. So yeah, you can see basically you can supply a pattern for this first argument and do all sorts of interesting transformations to the frequency distribution while the resynthesis is happening. So just to, I don't know, give one more example, let's make this go to an even more extreme logarithmic scale and then duplicate this so that it happens 7 times over the course of the 5 seconds. So you'll kind of almost get like a rhythmic movement through the spectrum. At least that's what I think will happen. Okay, so that's this one down here. Looks pretty crazy. Let's listen to it again. I actually don't know if you can hear that, so let's try this. Yeah, cool. Okay, so that's the frequency and then the duration. The third argument is speed. So you can also kind of change like resynthesis speed, where this defaults to 1, which just means that it will be 5 seconds. It'll be the duration that you specified here. But if you change this, so for example, if you make it a coefficient of 2, that means that the resynthesis will make it so that everything happens like, and the resulting file is twice as fast, so it'll be 2.5 seconds long. So we'll wait for that to resynthesize, and we should see that it ends up being about that long. Kind of changed scales on us, but you can see here that it is half as long as the first one that we had done earlier. And so this can also be a pattern, so you could start with something, you know, that's like a 1, which would be regular speed, and then kind of move to slower and slower speeds over the course of the resynthesis, and then ultimately, actually, I'm sorry, these are faster and faster speeds, so it'll like speed up more and more and more. So I think this will end up being shorter. Yeah. You can see, that's actually different than what I expected. That's really strange. I don't know if that's just, because this is 100 kilobytes smaller than this file. So what's going on here? I'm not sure why they looked the same length before, but anyway, you can see this one is indeed shorter than the other one. That might have been a bug in Audacity, honestly, weirdly enough. Cool. So those are kind of some initial demonstrations of what you can do with this resynthesize function. Well, it can get really interesting because you could make this like a minute long, right, or more. I've done like 6 minutes long, which would be 360,000 milliseconds. And you can wait, it'll take a while, but it'll resynthesize stuff that sounds like extreme time stretching. Um, and it is possible you'll hit like out of memory errors, but it's all just for fun exploration anyway. So, um, okay, so maybe just as one other example, let's just like load another file. Um, just something completely, I don't know, this is random, just pulling it up. And then let's set these arguments back to like just the default. So 1 ms 3000. Okay. So there's that one. And yeah, pretty much any PNG this will work with. So lots of fun opportunities to even like take a piece of paper, draw a score on it, and then you can sort of, in the analog world, take a picture of it, send it to your computer, and you've got your own spectral score, similar to like what Xenakis used to do with the UPIC system. There's a picture of my face on here somewhere. I'm going to see if I can find it. All right, I think it's this one. Copy this and just, why not? Then I'll move on to some other stuff. This is going to be quick because we'll see how the resolution is. It's a big image, but it's let's go back to here, drop that in. Yeah, I can see my face in that. There's my mustache and my hat and my arms. Cool. If you made this longer, I think that you'd be able to see like a slightly higher resolution of the image, since we've kind of compressed the picture information into this 3 seconds of time. I think it's actually harder to see. So you can see it's a better image here. Okay, so that's load image to resynthesize, so delete that. We also went over different frequency scales, duration, and time stretching. So I also wanted to talk a little bit about how to generate two-dimensional images in Facet, because you can basically like generate the images from scratch yourself rather than have to load in a PNG file. So here's a prepared example I can play later. I think I'm just going to walk through how you would do this first. So like my image, let's name the facet pattern. And this is something I like to do just to sort of give myself an understanding of how big the two-dimensional space is that I'm going to be working in. So generate 1 million samples of silence. So just a million zeros. And that means that this is going to be a 1000 by 1000 image. You could use the dim function and make it like a different width to height, so that is possible. But I'm just going to work with squares for now. There's a bunch of two-dimensional methods that you can use. Check out the README. Just for this example, I guess I'll just use like circle 2D. And here are the arguments to that. So you just apply the center frequency, so it'd be 499, would be the center of a 1000 pixel wide space. Let's make the radius of this circle 250 pixels, give it a value of 1, and then mode 0 is like don't fill in the circle, mode 1 is fill it in. So let's just do that for now, and then run save image.once. So then if we go back to the image directory and go up to the top here, here's what I just generated. Just a circle inside a black background. And by that point, you just take these save image.once calls off and instead resynthesize, and then however long you want it to last. 2000 milliseconds, dot full, dot play, dot once. So this won't save an image, it'll now be a new image. Oh, I guess we'll also have to dot save as spectral slash sts. So this just saves it into this spectral directory here where I've been pulling from. So there's our little circle. And if we want, we could iterate, I don't know, 16 times. And then each time do a different circle. So this dot circle 2D, instead of it being 499, let's just do a random integer between 0 and 999 for that, so that these are in random positions, and then make the radius of this circle a random integer between 50 and 500. And now we have 16 circles that are going to be kind of randomly dispersed through the two-dimensional space. So there you go. Let's make this bigger. Let's make this 4,000. So this would be a 2,000 by 2,000 space. So then we can kind of increase these values a little bit so that it still fills up the whole space, and maybe make this last 10 seconds instead. So it's going to generate, it'll take a little bit more time. It has to crunch a lot more numbers. This is all JavaScript in the end, and it's all good. It's fun to be able to experiment, and you can go look at the internet for a second while you wait. So there's that one. Now let's do ramp 1 to 8 over 32, do 127. So I don't really know what is going to happen. I think it's going to be a pretty extreme, like, hyper rhythm thing. That's what's so fun about this stuff, is like you sometimes don't know exactly what's going to happen, and I think oftentimes the bugs or the unexpected things can be the most fun. Yes, that was different than I thought. You can see that the circle is kind of getting moved around every time that there's a new frequency distribution. Anyway, there's a whole bunch of methods that you can use for two-dimensional synthesis and kind of, I don't know, different ways you can process two-dimensional information. Maybe one more I'll do before we'll move on is perspective 3D, which is like, it basically like puts in a vanishing point inside the two-dimensional space. I'll keep these arguments how they are, and then just put the vanishing point as like the middle point in the image. So 999 is the middle point of a 2000 by 2000 image here. You know what? That's actually going to be wrong, because this perspective 2D needs to be before the resynthesis. So we'll put that here instead. And run it again. Do. It'll be done in a second. Cool. You know, that was a little bit harder to actually see what's going on because of all the motion in the frequency distribution. So let's just put that back to 1 and run this one more time, and then hopefully you can kind of see what's happening a little bit more with perspective 3D. Yeah. Yeah, nice. Maybe even simpler. Let's just do one iteration of the circle so that we can really see like where the vanishing point is. And then I will move on. There you go. That's a better. So you can see that it's kind of making little copies that go closer, are losing amplitude. A little bit harder to tell here, but um, yeah, the center point is where whatever this random circle happened to be close to the center anyway, but if it was over here, the echoes would kind of tend towards the center. Okay. So let's look at this command for a second. Generate 4 million samples of silence. Generate gradient 2D, which is a method that generates a gradient. Kind of like a circle, but instead of being filled with the same value, it's a circle that is kind of just moving through different pixel values. And we actually don't need this prepare 2D method. Um, then you're just resynthesizing it so that it is a linear frequency distribution. It lasts a whole note, and then you're kind of stretching it according to different, so according to noise that's scaled between 1 and 2, and then each slice of that 32 samples of noise between 1 and 2 is like kind of stretched in its own way. Not really sure. I just wrote this command down a few days ago, so I'm curious what it will sound like. Okay, it's like a rhythm type thing. I'm going to save this into the same directory we've been working in, so we can pull it into Audacity and look at it. Yeah, so basically just like a weird little 32 note type rhythm thing that's kind of got some blurriness to it. Not really sure why I saved that for myself. Maybe just to, I honestly don't know. Okay, well, that's the two-dimensional image stuff. And then the last thing I wanted to mention is that you can also load audio files and interpret those so that they're prepared as spectral information, at which point you can do any sort of two-dimensional transformation on it and resynthesize it. So maybe like a simpler example would be to get rid of that and just say, okay, I have a sample called 1, 2, 3, 4, and I can play it. It's just my
1,
voice.
2, 3, 4.
So that's the simple load, sample, play it thing that you can do. um, if you run .spectral .resynthesize with a linear frequency distribution to last 5 seconds, it's basically just, there's no point in doing this really. You're stretching it a little bit in time, but it should work. It should be possible.
1, 2, 3, 4.
So then you can time stretch it to last 20 seconds if you want. Like this is going to take a little bit of time. And again, Facet's not like the fastest thing in the world. This is more for, I would say, like, at least for the way I like to use it, is just kind of crazy experimentation and finding weird zones. So hopefully this will be ready pretty soon. Um, and then we can.
1, 2, 3, 4.
Awesome. So that's a factor of like 5 times time stretching. So still can hear the voice, but definitely lasting a lot longer than the original sample. Okay, then the last thing is just like once you've interpreted this audio file into the spectral domain, you can apply two-dimensional transformations to it prior to resynthesis. So you can kind of like modify the spectral score at this point. And so in this case, I know that There are 147 columns in this spectral information. Um, I think I had like a done kind of my own goofy command before this to get that number. Just it's magic. Don't worry about it. Then for each of the columns in the two-dimensional data, shift it based on which column it is, modulo 32 divided by 32. So this ends up being like shifted more and more, like between 0 and 1, but then multiplied everything by 0.04. So long way of saying this will end up like applying kind of like a pitch shift that goes up and down and up and down. So um, see if we can hear it once it's ready, and I'm going to save it so we can look at it. Okay, let's run it again so we can save it. Maybe harder to tell in this image, like you can see that the low frequencies do get pushed up to the high and such. I'm gonna make it a little more extreme, um, just so you can kind of see what's happening a little more. So I just went from 0.04 to zero point 0.4, which means that it'll be a lot more drastic of a pitch shift. So we can keep them both open and look at the difference here. So like each column is kind of getting shifted more and more. The frequencies are going like down, or if they're at the bottom, they're getting wrapped back up to the top. Um, and you can do like I've done stuff before where it's just like a wiggly sine wave where like the I don't know why I'm saying this, but basically there's all sorts of crazy pitch shifting that you can do once you've loaded an audio file in here. There's a lot of different two-dimensional transformations you could do on that information. Um, okay, cool. Well, this was a fun, somewhat convoluted, and just ridiculous primer on how you can generate images in Facet, how you can do spectral resynthesis, and come up with some really crazy sounds. So, yeah, thanks for watching. Bye.